Hello everyone, welcome back to the another session in series of learning design and analysis of algorithms. This concept is binary search. So in the last session we were discussed about divide and conquer strategy. The applications of divide and conquer strategy is binary search. And also we do have other applications which are quick sort, merge sort, and even binary search. So this video will be going to discuss about binary search. Now let's begin. Divide and conquer can be used to solve this problem. As I told you, this is the application of divide and conquer. Now, so divide and conquer is what? So if you have still any doubt regarding divide and conquer, you just watch the previous video. So with that you will have more clarity. Divide and conquer means if we have a big problem, that big problem will get divided into smaller pieces. Now let small of p be true if n is equal to 1. In this case, s of p will take the value I, x is equal to ai. Otherwise, it will take the value of 0. Right? So the mean of this is when the problem is very small, that means when the problem is having a single element, the number of elements in the problem are 1, then the complexity of that is the growth rate of the function g of 1 is equal to theta of 1. Okay. If the problem is not having single element, if the problem is having more number of elements, then our x is equal to what? A of I. Now this ai should get divided into small subsets. That is, so that ai will get divided into small subsets, and these subsets are starts from a1 to an. Now a1 is low value, an is high value. Okay. So now divide and conquer strategy is dividing the task into subtask, but based upon what we'll do in this binary search. So how we'll apply divide and conquer here? So how we'll apply is we'll take middle element. We'll take middle element. What is middle element? Lower plus high value by 2. What is low value? Low value, the value which is pointing in the beginning. High value is the value which is pointing in the ending. So that means if these are my elements, now I'll give numbering to my elements which are called as indexes, right? This is my first element in my array and this is my last element in my array. So now count your elements: 1, 2, 3, 4, 5, 6, 7. So that means what? We do have 7 elements and my low element of the array is index is 1. My high element, that is my last element of my array index is 7. So 1 plus 7 by 2. 1 plus 7 by 2 is what? 8 by 2, which is 4. So now this is what my element till where I will make one subset. Okay. So what do you mean by this? Divide and conquer. How I can divide? Based upon this middle element. Based upon this middle element, we will be dividing the list into two parts. Now, so this algorithm is what? Binary search. So binary search means that the name itself, it tells that the searching operation will be in two parts. Binary means two. So searching operation will be in two parts. So that are, if my key element is what? My searching element. So the searching element is k. If k is equal to a of mid, that means mid position is what? 4. A of mid means what? The value which is available in the fourth index. Okay. Mid is index. Mid value is 4. A of mid in the sense the value which is available in this location is a of mid. Okay. If my key value is exactly equal to a of mid, then my search element is found. And the complexity of that is what? A of big of 1. Means in the first attempt I found my element. In the first attempt I found my element, and that will be the best case. Best successful case of binary search. Now, if it is not means my key element is not equal to a of middle position element, then we'll be checking this condition, key less than A of mid. Search operation will be in left side, because all the elements what we are taking or should be in a sorted manner. Array should be in a sorted manner. So once array is sorted manner, if I found my element here, that middle element is here, so all the elements which are left side will be smaller to this element. All the elements which are greater, which are bigger than this element will be in the right side, right? If you write any sorted manner, 1, 2, 3, 4. Let us suppose my middle element is of 3. Okay. So look at this. Left side elements, for sure these are lesser than the middle. Right side element for sure greater than the middle element. When my key element, if for example my key element is 7, now 7 double equal to 3. It is not equal. So my middle element is not my key element. The second condition is what? Second condition is what? K less than A of mid. What is key value? 7. What is A of mid value? 3. 7 less than 3. So obviously this condition failed, right? 7 is not less than from 3. So search operation will not be in left side. When this condition is true, so our element of this 7 will be left side. But this condition is failed. So element will be probably at right side. Fine. Element will be at right side. Now that's what we wrote here. Search operation will be in right side when this condition fails. So when this condition fails, search operation will be in the right side. Okay. Now we'll see the algorithm. Recursive binary search. So algorithm can be written in two ways. In recursive, using of recursive function, and using of iteration function. We'll see in the next paper. Okay. Recursive binary search. So first of all, what you have to do is you have to take this example. So as per this example, first value is what? My I value. I'm marking as I. So all the numbers are given as per the indexes. 1, 2, 3, 4, 5, 6, 7. Okay. Now middle is equal to what? I plus L by 2. I is what? 1. L is what? 7. 1 plus 7 by 2, which is 4. For example, if you got any fractional value here, that means 1 plus 8 by 2 means 9 by 2. So we'll get 4.5, right? We'll apply floor function here. If you have any value which is fraction, then we'll apply floor function. Floor means this value will be going to see that we'll floor it. Okay, we'll floor it. So we'll not seal it. Seal means what? The top value. Floor means what? That least value will take. Now look at the algorithm. So recursive binary search algorithm is algorithm binary search A comma I comma L comma X. What is A? My array. What is I? The starting index of the array. What is L? The highest index of the array. What is X? My key element. Now go ahead. So if L is equal to I means what? You have only single element. You have only single element. When I have single element, now this is my I and this is my L. When these both are equal, then we need not to divide any element, right? So if it is not, what it is not? If it is not, L is not equals to I, then we'll go to divide the main problem into sub problems. That based upon what the problem will get divided? Based upon the middle element. Mid is equal to I plus L by 2. And if X double equal to A of mid. So in programmatically, we'll write this is double equal to. As per the algorithm structure, we are just writing it is single equal to. Do not get confused. Okay. So in programmatical terminology, we'll make this as double equal to. X double equal to A of mid. But in algorithm, I'm just using single equal to. Even if you refer any textbook or the material what I have given you, if you see that also, you'll find single equal to. So that means that x is equalized to a of mid. So if it is equal, then we'll return that mid and that is my key element. And else if it is not, which is not, this is not equal to a of mid. So means whether it can be of lesser or it can be of greater. If it is lesser, so I'll call again my binary search function, because it is recursive function I said. So recursive means the function has to be called itself, right? So what the function has to be called, whichever split you are performing, that split we divided the whole p into two parts. One part is what, a of I to mid minus 1, the other part is mid plus 1 to L. This is what. So up to here it will be treated as one set. Means what, I to middle element is 1, middle plus 1 to L is one set. Okay, are you understanding? And I'm sorry, up to here mid minus 1, right? So it is mid minus 1, it is middle plus 1. So binary search will have these splits. The first split is what, I to mid minus 1. Next split is what, mid plus 1 to L. That's what I'm calling the function. When you have to call this function, when the key value is lesser than the middle value, then you have to call this function. When you have to call this function, when the middle value is greater than the key value, you have to call this function. So this will be happen recurrently or recursively. So again, until you found the element in the middle position, you will call this function again and again. Now let's see, 1 comma 3, again this array, this function will get called. So now I value will get changed, right? What is I value? 1. What is mid minus 1? 3. This time I value is 1, L value is 3. Now we'll get into the program. So what is here? L is equal to not I, because I is 1, L is 3. So 1 double equal to 3, condition fail, will come to this. 1 plus 3 by 2, 4 by 2 means 2. Now this 2 will be your middle position element. Now this will be middle minus 1, this will be middle plus 1. Okay. So until you found L is equal to I, you will be repeating this condition. So this is what recursive. This is what recursive. And we'll see iterative. Iterative binary searches. Algorithm binary search a comma n comma x. So low is equal to 1, high is equal to n. Low is what? The first index value. High is equal to n, means the size of the element. While low less than or equal to high, do. That means what? My low element is 1, my high element is n. So let us suppose my n element is 10. So 1 is less than or equal to 10. That means you have good number of elements in the list, not of 1. So when you found the list with greater than of 1 element, now you have to start the procedure. So the same procedure what I have explained you. So that mid is equal to low plus high by 2. Now again the comparison will get start with this x less than mid. So that means high is equal to mid minus 1. X greater than a of mid, low is equal to mid plus 1, return mid. Okay. This is what actually binary search, iterative binary search. Now the time complexity, for successful searches, best case is big O of 1. Average case is big O of log n. Worst case is big O of log n. Means if my key element for what I am searching is found to be in the middle position, then in the first hit only I found my element. So it is the complexity. The time which is required to find the key element is 1 cycle. So the average case is what? I have divided the list into 3 parts, right? These 3 parts. Middle part, mid minus 1 part, mid plus 1 part. So if it is not, if this condition get failed, now we'll come to this part. Which is this part? N by 2. Which is this part? N by 2. Means what? If you apply logarithm, then it will be of log n, it will be of log n. So whether you will search in this part or you will search in this part. So average case and worst case of algorithm is big O of log n. Okay. So unsuccessful searches, best average worst is big O of log n, because you have to search the complete set of the elements. So after you compare each element with the key element, you will be finding that element was not found. So hence unsuccessful searches time complexity is big O of log n. So this is all about what? Binary search. So the next video will make on merge sort. Thank you all.